Okay, so in order to make this, you start off with concentrated sulfuric acid. Now this stuff in and of itself is pretty nasty, but that's not going to work for diamond because diamond is already pure carbon. And so we need something else to be able to attack that carbon. We need some oxygen atoms. And so where I'm going to get that oxygen from is hydrogen peroxide. So I need about 50 mils of hydrogen peroxide. Now I'm going to slowly mix them together. Now this mixing is extremely exothermic, so I have to be pretty careful in doing it. I would stick my thermometer in here to show you how hot it's getting, but it would dissolve the thermometer. Okay, now watch what happens when I put a sponge in this. Now it's a completely clear liquid again. No sign of the sponge whatsoever. That is crazy. Okay, now watch what this stuff does to a hot dog. Okay, look at that. It is a clear liquid again. Okay, so how is that even possible? The sponge and the hot dog just dissolved and turned into thin air. There was just clear liquid left after. So where did it go? Well, what happened to it is it just turned into water and carbon dioxide with nothing left. The carbon dioxide bubbled off into the atmosphere and the water stayed in the jar there. I have here 2 real diamonds. So it's around 0.02 grams. Okay, now let's put it in here. See what happens. So 0.018 grams. So it does look like it lost a little bit of weight in there. So the piranha solution might have been dissolving it. I did see a very slight decrease, but I'm unsure of the quality of my scale, so it could have just been the variation in the scale itself. It was slightly less, but I'm not sure that that was actually due to some of it dissolving off as carbon dioxide or not. Now I could leave it in there for a long time, but eventually all of the hydrogen peroxide reacts and bubbles off as oxygen, and so you can't really have a long-term solution of this. Why are diamonds so hard and so resistant to any chemical reaction? Now diamonds have the highest hardness and the highest thermal conductivity of any material in the world. So diamonds are extremely hard and they're made 100% out of carbon. But I have something else here that's made 100% out of carbon that's really soft. So this is called graphite. Graphite is so soft that when you rub it on paper it flakes off, and that's how you use a pencil to write on paper. But with diamond you would have no such luck. So graphite is made out of carbon atoms that are connected to each other in this structure. And they're all bonded to each other like this. So in graphite, each carbon atom has 3 bonds associated with it. So this center one here you can see is bonded to this carbon, this one, and this one. And the way it stacks up is it makes these flat sheets together. So the carbon atoms that are in this sheet and this sheet, they're not really bonded to each other. They're only weakly bonded to each other. And so these sheets can slide past each other. So that's what makes graphite so soft. And so even though these bonds are really strong, these sheets slide past each other so easily that they can just flake off and you can write on paper with it. But in diamond, each carbon atom has 4 covalent bonds associated with it, and it stacks up in this cubic structure. So because carbon-carbon bonds are extremely strong, and also because there's no sheets like in graphite, that makes diamond the hardest material in the world. But that doesn't mean you can't break diamond or destroy it. If I just smash this with a hammer right now, I could break it. But they are pretty chemically resistant. That's because carbon-carbon bonds are pretty hard to break. And thanks for watching, and I'll see you next time.